This short presentation is about important subjects in classical mechanics, focusing specifically on the physics of a pendulum. We will explore the fundamental concepts of motion, forces, and energy that govern how the pendulum operates. By the end, you will understand not only the mechanics behind this fascinating device, but also its real-world applications in technology and science. Let's dive in. Okay, now let's mention some important objectives of the motion of a pendulum. One is understanding mechanics. Two, explore motion. Three, identify applications. So, now let's give an introduction to the pendulum. We are going to explore the fascinating motion of a pendulum. A pendulum consists of a mass known as a pop attached to the string or rod that swings back and forth under the influence of gravity. The main components of the pendulum include the pop, the string or rod, connecting it to a pivot point, and that pivot point itself, which is fixed in place. So understanding these components is crucial for grasping how a pendulum operates. The interaction between the force acting on the pendulum, specifically gravity and tension, determines its motion. Okay, now let's talk about the action or the force acting on the pendulum. Let's go deeper into the forces at play. The primary force acting on the pendulum is gravity, which pulls the pop downward, as it's shown. This gravitational force is countered by tension in the string or the rod, which acts along the length of the string, keeping the pop from falling. When the pendulum swings, its weight, the force of gravity, acts downward, while tension acts perpendicular to the motion. The balance of these forces is what allows the pendulum to move in a circular path. Now, the important section of this short video is the motion of the pendulum. Now, let's discuss the motion of the pendulum. For small angles, the pendulum's motion can be described as a simple harmonic motion. This means that the restoring force, that is, the force that brings the pendulum back to its equilibrium position, is proportional to the displacement from that position. We can calculate the period or the time it takes from the pendulum to complete one full cycle using this equation. T is the period, L is the length of the pendulum, and g is the acceleration due to gravity. This formula shows us that the length of the pendulum and gravitational acceleration affect how quickly it swings. Additionally, as the pendulum swings, It constantly transforms energy between kinetic and potential forms. When the pulp is at its highest point, it has maximum potential energy. As it swings down to the lowest point, that potential energy converts into kinetic energy, which is maximum at that lowest point. Finally, let's look at real-world applications of the pendulum. One of the most well-known uses is in clocks, where pendulums provide accurate timekeeping due to their regular motion. Additionally, pendulums are employed in seismometers, which measure ground motion during earthquakes. In conclusion, the pendulum is not just a simple device. It illustrates important principles of physics, such as energy conservation and harmonic motion. Understanding how a pendulum works helps us appreciate its applications in both technology and science. Thank you for watching.